Hey y'all, welcome to our Python for Data Science series. In this tutorial, I will dive deep into an intro to the fundamental concepts and syntax of Python programming, tailored specifically for aspiring data scientists. Whether you're new to coding or looking to brush up your skill, this video covers everything from variables to data types to loops and functions. Follow alongside step by step to build a solid foundation in Python and kickstart your journey into the world of data science. So I'm going to go over 11 slides for this video. We'll talk about an intro to Python for data science. We'll talk about what is Python. We'll discuss how to install Python, the Python basics, control structures, functions, libraries for data science, getting started with NumPy, exploring Pandas with NumPy, and exploring data with Pandas. I say Pandas, I feel like it's Pandas. And lastly, data visualization with Matplotlib. So Python has become a cornerstone in the realm of data science. And there are several reasons why it's widely regarded as the go-to language for anyone venturing into this field. First and foremost, Python is incredibly versatile. What does that mean? Well, it means that Python can be used for a wide range of tasks in data science. Whether you're wrangling messy data, analyzing trends, building predictive models, or creating stunning visualizations, Python has got you covered. One of the main reasons why Python is so powerful for data science compared to, let's say, Java is its extensive collection of libraries. These libraries are like pre-packaged toolkits that contain all sorts of functions and tools specifically designed to make your life easier while working with data. For example, there's NumPy, which stands for numerical Python, and it's fantastic for numerical computations and array manipulation. Then there's Pandas, which is excellent for data manipulation and analysis, allowing you to slice, dice, and reshape your data with ease. And let's not forget about scikit-learn, which provides a vast array of algorithms for machine learning tasks like classification, regression, and clustering. But Python isn't just about crunching numbers and analyzing data. It's also great for visualizing data. Libraries like Matplotlib and Seaborn allow you to create beautiful publication quality plots and charts to help you better understand your data and communicate your findings effectively. Speaking of machine learning, Python is a language of choice for many data scientists and machine learning engineers. But why? Well, because of the libraries like TensorFlow and PyTorch, which provide high-level APIs for building and training deep learning models. These libraries abstract away much of the complexity involved in implementing neural networks, allowing you to focus on experimenting with different architectures and hyperparameters to find the best model for your data. And let's not forget about the Python community. One of the best things about Python is its large and active community of developers and data scientists who are always eager to help out newcomers. Whether you're stuck on a coding problem, need advice on which library to use, or just want to share your latest data science project, you'll find plenty of support and camaraderie within the Python community. So, whether you're just starting out on your data science journey, or you're looking to expand your skills, Python is the perfect language to learn. Its versatility, extensive libraries, powerful visualization tools, support for machine learning, and the vibrant community make it an indispensable tool for any aspiring data scientist. Python is often described as a high-level programming language, but what exactly does that mean? Well, think of it like this. When you're programming in Python, you're working at a level of abstraction that's closer to human language than it is to machine language. That means that you don't need to worry about the nitty-gritty details of how the computer actually executes your code. Instead, you just focus on expressing your ideas and solving problems in a way that's intuitive and easy to understand. So one of the key reasons Python is so popular in data science is because of the simplicity and readability. Unlike some other programming languages that use complex syntax and obscure symbols, Python syntax is clean, straightforward, and easy to read. This makes it particularly well suited for tasks like data analysis and machine learning, where understanding and interpreting code is just as important as writing it. For beginners, the simplicity and readability are game changers. That was me. It means that you can spend less time wrestling with the language itself and more time actually working on the data science project. Plus, it makes collaborating with others a breeze since anyone can quickly grasp what your code is doing just by looking at it. I do recommend to add comments to your code though. So whether you're crunching numbers, building predictive models, or creating visualizations, Python's high-level nature and its emphasis on simplicity and readability make it the perfect language for diving into an exciting world of data science. So, how do you install Python onto your computer? Well, that's the first step, so it's a good idea that you're thinking about that. Thankfully, Python is highly compatible with different operating systems. So whether you're using Windows, Mac OS, or Linux, here's a basic guide on how to install Python. I will insert a step-by-step instruction for each operating system. So we'll start off with Windows, and then we will go into Mac OS, and then we will go into Linux, and that's it. So just pause the video, take a screen grab, follow the instructions, and then continue watching this video. So once you have Python installed, you may want to explore different distributions that offer additional tools and libraries tailored for data science. So one popular choice is Anaconda. Anaconda not only includes Python, but also comes with a variety of pre-installed libraries and tools commonly used in data science, such as what we just discussed, NumPy, Pandas, and Jupyter Notebook. It also provides a convenient package manager called Conda, which allows you to easily install, update, and manage packages and environments for your projects. Installing Anaconda is as simple as downloading the installer from the Anaconda website and following the installation instructions provided. With Anaconda, you can kickstart your data science projects without worrying about the hassle of installing and configuring individual libraries later on. Up to you. I use Anaconda as well as IntelliJ. So in Python, variables are like labeled containers that you can use to store different types of data. You can think of them as placeholders for your information. So to create a variable, you simply choose a name for it and assign a value using the equal operator. So for example, x equals 5, name equals John. Here, x is a variable storing the integer value of 5, and name is a variable storing the string value John. What's good about Python is that they are dynamically typed, meaning that you don't need to specify the type of data they will hold. Python figures it out for you, and that's another beautiful feature of Python compared to Java. Data types. So Python supports several fundamental data types. We have integers, which are just whole numbers without decimal points, like 5 or -10. We have floats, which are numbers with the decimal points, like 3.14 or -1.10. We have strings, which are textual data enclosed in single or double quotes, like hello or Python. Lists are ordered collections of items enclosed in square brackets and separated by commas, like 1, 2, 3, or apple, banana, orange. Tuples, those are immutable ordered collections of items, which are enclosed in parentheses and separated by commas, like 1, 2, 3, or red, green, blue. Dictionaries are unordered collections of key value pairs, enclosed in curly braces with each pair separated by commas, like name, John, age, 30. Sets are unordered collections of unique items enclosed in curly brackets and separated by commas, like 1, 2, 3, or apple, banana, orange. Python supports various basic operations to manipulate your data. So we have arithmetic operations, which include addition, subtraction, multiplication, division, exponentiation, and modulus. We have the comparison operators, which include equals to, not equals to, greater than, less than, greater than or equal to, and less than or equal to. Logical operators include and, or, and not. They are used to combine conditional statements. Understanding variables, data types, and basic operations is essential for writing Python code to perform calculations, manipulate data, and make decisions based on conditions. Conditional statements in Python allow you to control the flow of your program based on certain conditions. So the most basic form is the if statement, which checks a condition and executes a block of code if the condition is true. You can also use else if to add additional conditions to check if the first condition is false, and else to execute a block of code if none of the previous conditions are true. Loops allow you to repeat a block of code multiple times. So in Python, you can use a for loop to iterate over a sequence of elements, such as lists or strings. You can also use a while loop to continue iterating as long as a certain condition is true. In data science tasks, control structures like conditional statements and loops are invaluable. So for instance, you might use conditional statements to filter out irrelevant data points based on specific criteria or to handle missing values in your data set. Loops come in handy when you need to iterate over large data sets, to perform calculations or pre-process the data before analysis. You might use a for loop to iterate over each row in a data set and calculate summary statistics. or a while loop to train a machine learning model until a convergence criteria is met. Understanding how to use conditional statements and loops effectively is essential for performing data manipulation, analysis, and modeling tasks in Python. These control structures give you flexibility to write code that adapts to different scenarios and effectively processes large volumes of data. Functions are like mini programs within your main program. They allow you to break down complex tasks into smaller, more manageable pieces, making your code easier to understand, maintain, and debug. Functions also promote code reusability since you can call them multiple times from different parts of your program without having to rewrite the same logic. To define a function in Python, you use the def keyword, followed by the function name and parentheses containing any parameters the function accepts. Inside the function, you write the code that defines its behavior. To call a function, you simply use its name followed by parentheses containing any arguments you want to pass to it. Functions can accept parameters, which are placeholders for values passed to functions when it's called. Parameters allow functions to operate on different data or customize their behavior based on input. Additionally, functions can return values using the return keyword, which sends the results of the function's computation back to the caller. So in this example that I have on the screen, the add function takes two parameters, x and y, adds them together, and returns the result. When the function is called with arguments 3 and 5, it returns 8. Which is then assigned to the variable result and printed to the console. So understanding how to create and use functions, including passing parameters and returning values, is fundamental to writing clean, modular, and effective code in Python. Functions help you organize your code logically, promote code reuse, and improve the readability and maintainability of your programs. So as I spoke about earlier, we have NumPy, Pandas, Matplotlib, and SciPy are 4 fundamental libraries in Python ecosystem, particularly in the realm of data science. They provide essential tools and functionality for tasks ranging from data manipulation to visualization and scientific computing. So I'll provide a brief overview of each of the 4. We'll start off with NumPy, and that's pretty much the fundamental package for scientific computing in Python. It provides support for multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays efficiently. NumPy's arrays operations are significantly faster than traditional Python lists, making it essential for numerical computing tasks. Pandas is a powerful library for data manipulation and analysis in Python. It offers data structures like data frame and series, which are designed to handle structured data easily. With Pandas, you can perform tasks such as reading and writing data from various file formats, cleaning and pre-processing data, filtering and sorting data, and performing descriptive statistics. Matplotlib is a versatile plotting library for creating high-quality visualizations in Python. It provides a wide range of plotting functions and styles to create various types of plots, including line plots, scatter plots, bar plots, histograms, and more. Matplotlib's flexibility and customization options make it suitable for creating publication quality plots for data analysis and presentation. SciPy is a library that builds on top of NumPy and provides additional functionality for scientific computing tasks. It includes modules for optimization, integration, interpolation, linear algebra, signal processing, and more. SciPy's extensive collection of functions and algorithms make it indispensable for scientific computing and numerical analysis in Python. In summary, NumPy, Pandas, Matplotlib, and SciPy are essential tools for any data scientist or researcher working with Python. They provide the foundation for data manipulation, data analysis, data visualization, and scientific computing, empowering you to tackle a wide range of data science tasks efficiently and effectively. So NumPy arrays are the cornerstone of numerical computing in Python. They provide a way to effectively store and manipulate large data sets of numerical data. NumPy arrays are similar to Python lists, but offer several advantages. So the first is that it's faster computation. NumPy arrays are implemented in C, which makes them much faster for numerical computations compared to native Python lists. There's also better memory efficiency. NumPy arrays consume less memory than Python lists, making them suitable for working with large datasets. NumPy arrays support vectorized operations, which allow you to perform element-wise calculations on entire arrays without the need for explicit looping. NumPy provides a comprehensive library of mathematical functions for array manipulation, including linear algebra, Fourier transforms, random number generation, and much more. Array manipulation in NumPy involves various operations to create, access, and modify arrays. You can create NumPy arrays using functions like np array, np zeros, np ones, np arrange, and np random. These are all functions that are built in. So, indexing. You can access individual elements of an array using square brackets and specifying the indices of the elements you want to access. You can slice as well. Slicing allows you to extract subarrays from an array by specifying a range of indices or using Boolean arrays to filter elements. You can also change the shape and dimensions of an array using the reshape function, which allows you to convert arrays between different shapes without modifying the underlying data. So for example, what I have on the screen, you can create an array, index an array, slice an array, reshape an array. So understanding how to manipulate NumPy arrays is essential for performing numerical computations and data analysis tasks efficiently in Python. By leveraging the capabilities of NumPy arrays, you can streamline your code, improve performance, and unlock the full potential of numerical computing in Python for data science. So the Pandas data frame is a two-dimensional labeled data structure with columns of potentially different types. It is similar to spreadsheets or SQL table with rows and columns and offers powerful capabilities of data manipulation and analysis. Data frame is the primary data structure used in Pandas and is widely used in data science, machine learning, and statistical analysis tasks. Pandas data frame provide a flexible and intuitive interface for working with structured data, enabling tasks such as data cleaning, transforming, aggregating, and visualization. Pandas provides several functions for loading data from a various file format into a data frame. So we have the read_CSV function, read_Excel function, read_SQL function, read_JSON function, and read_pickle function. They all provide different functionalities, and I'll put all that on the screen. These functions automatically infer the data types, handling missing values, and provide options for customizing the import process, such as specifying column names, data types, and index columns. Data frame operations in Pandas include various tasks for data manipulation and analysis. So to index, you can access specific rows and columns of a data frame using labels or integer-based indexing. Extracting subsets of data from a data frame based on specific criteria or conditions, filtering rows of a data frame based on Boolean conditions or column values, and you could summarize. Calculating descriptive statistics for data frame columns such as the mean, median, standard deviation, min, max, count, and more using the... So understanding how to work with Pandas data frame enables you to efficiently manipulate, explore, and analyze structured data in Python. Pandas provides a powerful and intuitive interface for handling various data analysis tasks, allowing you to extract insights and make data-driven decisions effectively. Matplotlib is a powerful plotting library in Python that enables you to create a wide variety of visualizations, ranging from simple line plots to complex 3D plots. It provides a MATLAB-like interface for generating plots, making it easier to get started for users familiar with MATLAB. Matplotlib is widely used in various fields, including data science, scientific computing, and engineering, for visualizing data, exploring patterns, and communicating the findings. Matplotlib allows you to create basic plots using functions from the matplotlib.pyplot module. Some common types of basic plots include line plots, scatter plots, bar plots, and histograms. They each serve their specific purpose, as you can see on the screen right here. Customizing plots. So Matplotlib offers extensive customization options for plots, allowing you to tailor the appearance of your visualization to meet specific requirements or preferences. So some common customization options include adding titles and labels to your plots to provide context and clarity, customizing colors, line styles, marker styles, and fill styles to enhance visual appeal and distinguish different elements in the plot, including legends to provide explanations for the plot elements such as data series or categories. Also adding text annotations, arrows, or shapes to highlight important features or events in the plot. So as you can see on the screen, I have some examples of creating a line plot, creating a scatter plot, creating a bar plot, and creating a histogram. Feel free to pause the video and look at the examples more in depth. So understanding how to create and customize plots using Matplotlib enables you to effectively visualize and communicate insights from your data, making it an essential tool for data analysis and visualization in Python. That is all that I have for this introductory video. I hope you learned a lot. I hope you understand a little bit more about Python and its different libraries. If you have any questions or comments or suggestions for any next videos, please put that down in the comment. Also, like the video, subscribe to my channel if you haven't. I do tech videos. I started with Java. I'm doing Python. I also do Tableau videos. So just subscribe to my channel so you can get notified of my next video. That's all that I have for right now. I'll see you on the next video. Peace.